Welcome to the recording of CSC108 Debugging and Exceptions. In this course, we're going to take a step back, and instead of learning a lot of new constructs and programming techniques, we're going to take a look at how we can actually handle problems and errors in our program instead. So we have two main objectives for today. First, we're going to look at what we call the debugger. And the debugger is a very useful tool for figuring out problems in our programs. And then the second half of the class, we'll talk about exceptions. And exceptions are used to actually report problems or errors. And we'll talk about how we can actually catch and handle those, because in previous classes, we saw that when something happens in our program actually crashes. And we're going to look at exceptions and how we can handle those exceptions so that our program no longer crashes. So let's get started by looking at the debugging process from a high level. So we're going to first start talking about what exactly debugging is, and then we'll talk about some of the tools and features available in Visual Studio. So the question comes, why do we care about debugging and exceptions? And it really becomes a problem for our users. Our users expect the application to work and work properly, and applications that perform poorly will end up being deleted from the device. So we want our application to function properly, so learning these debugging techniques can help us remove all the bugs before our users see them. So what exactly is a bug? And the easiest way to describe this is that a bug is something in your application that you do not intend to happen. So for example, your app could crash, your application could produce unexpected results, it could have unexpected behaviors, just something that you're not expecting to happen. So the process of finding and fixing these bugs is referred to as debugging, and this is a critical part of the software development process. Almost every program starts out with bugs because programs are far too complex to create them perfectly the first time, and your job is to find the bugs and fix them so that your program runs correctly. And once we recognize that there is a bug in our program, the debugging process has two steps. The first step is to isolate and find the bug, and then this is actually the hardest step, but once the bug is found, correcting it is normally pretty easy. So the C# compiler will actually help you find syntactical issues and common problems, because errors in your source code cause the compiler to fail, but the C# compiler also produces warnings which indicate that the code can be compiled and that it's valid, but it's not necessarily correct. So you want to make sure you pay attention to warnings because they often predict issues that can happen in the future. And these kinds of compile time errors and warnings are fairly easy to fix, and they're inexpensive, because the earlier you find a bug, the less expensive it is to fix it because it involves less people and less time. Now, once your program compiles, then you begin testing it. And bugs that happen while the program is running are referred to as runtime bugs. And they're harder to find and fix because they often happen only under certain circumstances. And even worse, sometimes bugs slip through your testing and end up happening to your customers. And you probably have experienced this frustration of dealing with your mobile device not behaving correctly or having applications that just go away while you're using them. And these are bugs either in the OS or in the program. And these are the worst kinds of bugs because it reduces the customer's trust in the program and potentially hurts the reputation of the developer or company that's creating the software. So one thing to keep in mind is that the more complex the software gets, the more of a chance there is for unknown bugs to be present in the code. And in fact, often fixing one bug may lead to introducing another. So it's important to test and debug your application to ensure that we have the highest quality software possible with the fewest bugs. Now, the tool that we're going to use for debugging is called a debugger. And this is really a part of all modern IDEs today, and it allows you to execute your code in a controlled environment, being able to stop it at specific points and kind of examine the internal state of your application. And we activate this tool by loading our project into the IDE and then using the play or run button in the toolbar to start debugging. You can also press the F5 key. And this will compile the program if necessary and then start the program running in debugging mode. And you can then pause, inspect, and even modify values to force certain conditions to occur, which will hopefully reproduce the issue that was identified before. So when your code is executing in the debugger, one of the ways that you can isolate a bug is to pause the program execution at a specific spot where you suspect things are going wrong. And you can direct the debugger to stop execution on a line of code by inserting what we call a breakpoint. So before your program executes a line of code that the breakpoint is on, it will stop and allow you to examine the variables and the state around that breakpoint. And then you can continue execution either line by line or just allow the program to run from that point. And each time it encounters a breakpoint, it will stop. So for example, you could place a breakpoint in a loop, and then each time the loop is executed, the debugger would pause the program. Now you can also right-click on a breakpoint to get to a dialog that gives you additional control over your breakpoint. And this will allow you to control what happens when the breakpoint is hit. By default, the code will be paused for you to inspect values. But by using the dialog, you can place additional conditions to limit when the breakpoint will pause execution. So for example, you may only want to break when an integer variable is negative, which could maybe indicate a problem with the data. You can also specify an action when the breakpoint is hit. An action in the context of a breakpoint has a special meaning. The first thing it allows you to do is to output data into the output window. And this could be useful to check the value of changing variables. So maybe you're inside of a loop, for example. And you also have the option of continuing execution when the breakpoint is reached. And this allows you to log the data to the output window without pausing the application. Now we also have several other great debugger features that you can use when the program is paused on a breakpoint. So the first is the locals window. This allows you to see all of the active local variables that are in memory and available to the method that you're stopped in. And we call this being in scope. So when you hit a breakpoint, all of the variables that are in scope to that breakpoint will be accessible through this locals window, and you can use it to see the state of your application. You can quickly see what data is inside of your variables and your fields. Now, the watch window is another tool that we can use when the application stops at a breakpoint. Now, this allows you to type in specific variables that you want to monitor, and each time the program stops, the value will be updated. Now, this is similar to the locals window, except that it only displays the variables that you select, and they stay in the window until you clear them out. So even if the variable is not in scope, it will still be displayed here, just showing a message indicating that it's not valid at that point. And then finally, we have the call stack window. And this allows you to determine exactly how you got to a certain spot in your program. It will show you a list of methods indicating the logical path that was taken to end up at your breakpoint. And it displays relevant details about each method that led up to the current one, including the name, the parameters, and even the source file if it's available. So what I want to do is I want to jump into our first exercise and show you some of these tools in action. So here we are in the starter solution for exercise number 1. And so far we have program.cs and we also have a person.cs. The person class represents a person, so you can see it has information like the person's name, its age, and how many siblings it has. And if we run the program to start off with, you can see we have this method called getPeople that's just creating some random people, some random ages, and some random number of siblings. If I run this program, though, there is a problem. So let's go ahead and compile this. And here's the output. Notice how, for example, Bobby, who is 16 years old, has 2 siblings. And notice how they're 1 year older for their birthday, that's fine, but it says that Bobby has no siblings. And it actually says all of our people have no siblings. But as you can see here, they actually do have siblings. So we have a bug somewhere in the program. And I want to just go through some of the tools that we can use to help figure this out. So I'm going to start off with just putting a breakpoint on the line that displays their age and name. So in the little gutter on the left-hand side, this gray bar, I'm going to select right there. And as you can see, it turns that line red. So this is now a breakpoint. If I run the program by clicking the play button, you can see it's going to compile the program, and then it's going to hit this breakpoint and pause execution. So as you can see, in our output, we only see happy birthday everyone, but we never display anything else because we're hitting a breakpoint. Now, without doing much, I can put my mouse directly over these variables, and I can see state. So notice how if I put my mouse over name, it says Rachel, because Rachel's the first person that we're trying to display. So this property is actually holding that value. And if I do age, you can also see it shows the correct age. Now, this is what we mean by scope. So to this breakpoint, name and age are in scope. So if I go to the locals window down here and I expand this, you can see all the things that are in scope to this breakpoint are age, name, and siblings. The 3 public properties are in scope. And you can see all of their values here as well. If we switch to the watch window, notice how there's nothing in the watch window. But I can add things. So remember, in here I could type, okay, let's say I want to track the name and I want to watch the name. If I type name here, hit enter, you can see now I'm watching it, and now Rachel is showing me I'm watching this value. I can also highlight a word, drag it, and I can drop it into my watch window. And now you can see I'm watching the age as well. So that's the locals in the watch window. Now, on the right-hand side, you can see I have the call stack. The call stack, remember, shows how we got to this point. So which methods called which methods to call this method. And you can see it says the main method, which is in program.cs, called this haveBirthday method. And now we're in here on line 17. You can see there was no parameters, but you can see all the information about that call. So let's go ahead and stop this. Let's remove this breakpoint for a second. So we know the problem is coming when we display how many siblings we have. So if we go to the describe family method, this is where it's saying how many siblings we have. So there's definitely a problem here. So I'm going to place a breakpoint on this if statement. And what I want to figure out is when this method runs and siblings is actually greater than 0, I want to figure out what's going on. So I'm going to say I want my breakpoint. I'm going to right click on that breakpoint. I'm going to go to conditions. I only want this breakpoint to run when siblings is greater than 0. And notice how I got IntelliSense there. It's really cool. I have IntelliSense in this dialog. And now that I added this condition, this breakpoint will only get hit when siblings, that property, is greater than 0 in that context. So in theory, when I run it, it should only start hitting the breakpoint on Bobby. So let's go ahead and hit play and let's see. So we hit the breakpoint and look at our locals window. Let's go to our locals window for a second. Notice who's in the current state, Bobby. So we hit the breakpoint because siblings is greater than 0. Okay, let's see what happens. So on the top of Visual Studio, these 3 buttons are used for debugging. So we have step into, step over, and step out. So step into will go to the next line of code, and if the next line of code is a method call, it will jump into the actual code for the method. Step over will go to the next line of code, but if it's a method call, it will jump over the method call and just continue staying in the same file. It won't go into the method. And then step out is if you are inside of a method and you click step out, it will back out of that method and go back to whoever called it. So it doesn't really matter which one I use here. I'm going to use step into. So you can see right now siblings is 2. If I step, that means go to the next line of code. And look what happened. The next line of code executes has no siblings. If I keep on going, you can see it skips over that, and then it basically returns has no siblings. So that's our problem right there. We just found it. We said this breakpoint should only go off if we have more than 2 siblings, which it did, but on top of that, it said has no siblings. So there's definitely a problem here. And the problem can be found on this line of code. If you read this, it says if siblings is greater than or equal to 0, then say has no siblings. This should really be if siblings is equal to 0, then say it has no siblings. So we just found the bug. Let's try running this program again. And as you can see now, it says Rachel has no siblings. That's correct. Bobby has 2, John has 1, and Mary has 4. So now everything's working correctly. So we were able to use the debugging tools that are available to us to figure out what exactly the problem was. So now let's do a flash quiz. And remember, with flash quizzes, I'm going to read the question and then I'll pause for a second to give you some time to pause the video and answer it to yourself. And then after that, I will go over it. So question number 1. What can you use to stop your program and examine values? So the answer here is a breakpoint. Remember, if you add a breakpoint, by default, the execution of your program will pause at that breakpoint. Number 2, what can you use to evaluate variables and expressions and keep the results? So the answer here is the watch window. So yes, remember, with the watch window, you get to decide which variables are present in that list, and they'll stay there forever until you delete or clear the watch window. Number 3, how does the IDE assist you with the debugging process? Now this answer is a little bit confusing, but we have A. It helps you by detecting and correcting errors. So far in this first objective, we talked about what debugging is and how we can actually use it in Visual Studio. We looked at cool things like adding breakpoints, using the watch and local windows, and also looking at the call stack to see how you got to a certain method. Now that we've tried out debugging, let's look at how C# notifies your program about critical failures and exceptional conditions. So we're going to introduce the concept of exceptions, how they're used, how you can catch them, and what you should do in response. So in the real world, bad things happen. Web services go down, power dies, disks crash, computers run out of memory, and networks lose connection. And when these environmental things happen, our program needs to be told about them in a standardized fashion. And that's the purpose of exceptions. They describe exceptional conditions that occur while your program runs. And this is done by creating a special object called an exception in the system namespace, which has properties that indicate where the problem occurred and some descriptive information about it. When an exception occurs, the program enters a special state and normal processing of the code is halted. An object is generated that will contain information relating to that error. And this object is an instance of an exception class. The most basic of the exception classes is the class called exception, which is defined directly in the system namespace. Now, exceptions are also used to indicate errors in our programs. So for example, a method that expects certain sets of parameters can notify the caller that it did not receive those expected parameters by throwing an exception. And by default, exceptions will actually cause your program to stop executing code immediately. And C# actually includes special keywords like try, catch, and finally to work with exceptions so that we can handle them when they occur and we can try to recover from them so that we don't just crash the program. So .NET defines a special exception class that you can see here to represent an exceptional condition in your code. And this object has public properties that contain information describing the error and also the location of the error. Now, some of the most important and helpful properties are the message, which is a string that describes what the exception or problem was. The source, which is a string that contains the name of the program or the object that caused the exception. We have target site, which is an object containing details of the method that caused the exception. We have the stack trace, which is a string that contains the complete stack of calls that led to that exception. And this string allows you to review each method call made up until that exception occurred. And this is especially useful during testing and debugging. Now, the exception classes are organized into a hierarchy with exception at the top. And beneath the exception class are various exception classes that have specific failures that can occur at runtime. So some examples of these are, we have argument null exception, argument out of range exception, divide by zero exception, stack overflow exception. And you can see for the most part the names help you figure out what is going on. So for example, argument null exception means that you passed in an argument that was null but needs to be a value. Divide by zero exception means that you're trying to divide by zero and you can't do that. Null reference exception means you're trying to access an object that is null. And then finally, out of memory exception means that you ran out of RAM and you have no memory to allocate new objects, meaning you can't use the new keyword. And by the way, that is extremely rare to see. We don't really see that error because computers have lots of RAM available, so you don't really see that often, but it does exist. So the next question that comes up is, why do we use exceptions instead of just returning some type of value to indicate a problem occurred? For example, take a look at this int.Parse method. We've used this many times in the past. Int.Parse is responsible for taking a string and converting it into an integer. But look at this example. We're passing as a parameter the value 1 as a string, O-N-E. The problem with this is, well, how would we report that something went wrong? What should we return from this method? Should we return a 0, a 1, or a -1? Like, what indicates that there was a problem? And the problem is we can't use any of these because int.Parse returns an integer normally. So if it returned a -1, how would we know that we weren't just passing in a -1 as a string and getting that back as an answer? We really can't differentiate between a successful conversion and a failed conversion using a return value technique like this. So because there's really no valid result that we can return from this will actually throw what we call a format exception to indicate that the passed in parameter or argument is not in the correct format and that it wasn't able to do its job. So if you don't handle this, it's called an unhandled exception. And that will actually reach the C# runtime, which will cause an immediate termination of the program. And this means that you'll almost always want to handle these exceptions in your program. And we can do this through two new keywords, which are try and catch. Now, when uncaught exceptions are detected in the debugger stops automatically and shows you the problem along with the tooltip bubble indicating the exception type, as you can see here. But the question is, well, how do we handle these exceptions? So like I said, C# provides a code structure known as a try-catch block, and this permits the handling of exceptions. A basic try-catch block has two elements. First, we need to surround the code that can potentially throw an exception in a try block. And the try block starts with the try keyword and then contains one or more C# statements within the braces. And then we use the catch keyword to handle a specific exception type. And again, with an associated code block which will be executed when an exception is detected. So in this case, we're trying to catch any format exception error which may come from the int.Parse method. Now, any exception that occurs inside the try block causes the code in the catch block to be executed. And the catch block can be used for various purposes, including graceful recovery from an error, logging, reporting of details of the problem, maybe freeing up resources. But once the catch block has finished executing, or if no exceptions occur within the try block, then the program continues with the next statement after the try-catch statement. So when developing complex routines, it's possible that many different types of exceptions could occur, and each of these exceptions may require handling in a different manner. And to allow for this, C# allows you to add multiple catch blocks to the try block. And each catch block handles a different exception type, with the most specific types processed first and the most generic types processed last. And when this is done, each catch block is checked in turn to see if the exception thrown is the same type as or derives from the declared type in the statement. And when a match is found, the code within the catch block is executed, and only one catch block's code is ever executed, and exceptions thrown that do not match any of those declared types will remain unhandled. So catching specific exception types provides two benefits. So first, weird exceptions like out-of-memory exceptions will go uncaught, which is actually a good thing because they're very rare to see, and you don't want those to be hidden by other exception types and kind of get pushed under the rug. And the second reason is that if there are any additional properties that are associated with that exception class, then they're made available to you in the catch block. So if you want to make sure all exceptions are caught, you can add a catch handler for the base exception type, as you can see here on the last line, and that means that if any exception is thrown, it will be caught in that because every exception derives from the base class exception. Now, one last point on this code, notice how that most of the exceptions have a variable name. And this allows you to access the properties of the exception, such as the message or stack trace, within the body of the catch block. However, if catching the exception type is enough, and it's not necessary to examine the exception properties, then there's really no need to include a variable name for the exception object. So the divide by zero exception is written that way here. You still need the block of code even if it's empty, but the parameter name can be omitted if we don't need access to those properties of that exception. Now, sometimes you need to ensure that some code executes whether an exception occurs or not. So for example, if a file is opened before a block, this file should be closed following the successful processing or an exception. And C# defines an additional block that may be added to the end of the try-catch statement, and this is the finally block. So the code within this section is guaranteed to execute after the try and catch, even if any exception is thrown, or the try block includes a return statement. In fact, it's called even if no exception handler is found, so even if no matching catch block is present, the finally will still always be invoked. And it's possible to use try and finally together with no catch blocks. If an exception occurs, it remains unhandled and it's thrown to the calling method or the C# runtime. However, the code in the finally blocked is executed whether an exception is raised or not. So during normal processing, it's possible for an error condition to be detected. And in some languages, you may exit the failing method early and provide a return code to indicate the status. And in fact, this is quite common in very early languages like C. Now, you could take this approach with C#, and sometimes you may want to, but it does not take advantage of the exception handling features provided by the language. It's always preferable to raise or throw exceptions explicitly when an error condition occurs and allow the exceptions to be captured by try-catch-finally blocks or by the C# runtime. So let's talk about some kind of rules. So you should throw exceptions only when an unexpected or invalid activity occurs that prevents a method from completing its normal function. Exception handling should not be used for normal program flow instead of conditional processing. Because exceptions interrupt the normal program flow, they're quite hard to trace through and they'll lead to maintenance problems in the code. So some examples of good uses of exceptions are throwing an exception when an invalid parameter value is passed to a method, or maybe throwing an exception when a call is made to a method that cannot operate because other steps must be taken beforehand. So let me add to this for a second. If the error is an expected one, so let's say, for example, if you know that 50% of the time this problem can happen, then you should prefer to return an error code and use an out or ref parameter to return the output. And we've seen this with int.Parse. But exceptions are expensive to throw. So if you overuse exceptions, it will affect the performance of your application. So here you can see a new method that expects a name parameter. And if that parameter is not supplied, being null, or maybe it's an empty string in that case, then we can't process this method and therefore we would want to throw an exception. Now, the exception is an exception object containing the details of the error being raised. And this can be declared as a new object and initialized before the throw statement, or it can be included inside the throw statement like you see here. Now, the class of exception object to throw should be appropriate for the error condition. And each exception object has constructors that may differ from that shown here, and you can consult the MSDN documentation for details. So in this case, we throw an argument null exception, and we pass the name of the invalid parameter. This exception would then need to be caught by the caller or identified by the developer, who could then examine the parameter name property, which is a unique property to this specific argument null exception, which can then be used to figure out which parameter was incorrectly passed in. Alright, now let's do another flash quiz. Question number 1. What are the exception handling keywords? And the answer here is D, all the above. Try, catch, and throw are all keywords specific to dealing with exceptions. Number 2, at what point does the catch block execute? The answer here is B, only when the try block throws an exception. So now what I want to do is I want to jump into our last exercise and talk about how we can throw, catch, and handle exceptions. So here we are in the starter solution for exercise number 2. And we have a basic program that we're just trying to display a list of names into the console. If I start off by running this program, notice what happens. It says Jesse, Mark, blank, Stacy. And if you look at the list of names here, you can see Jesse, Mark, null, Stacy. The problem is when we have null in this list, it's displaying nothing, but we would rather have it display maybe something like anonymous name. So as you can see, there's a bunch of to-dos, and our first to-do is inside this say hello method. This is what's actually adding what we're trying to say to our list of messages. So our first to-do is, it says use string.is null or empty to test the passed parameter. If it's empty or null, then throw an argument null exception. So what we're going to say is we're going to say if string.is null or empty, passing in our name parameter, then we're going to throw a new argument null exception. And as you can see, for a parameter, it asks for the parameter name that was incorrect. So we'll say, oh, that was the name parameter. So we now threw an exception, and if we run this now, notice what happens. Our program crashes throwing an exception. We now need to handle this exception by the caller. So who's the caller? The caller is this guy over here. This for each loop is calling that say hello method. So what we want to do is we want to say, okay, well, if an exception is thrown calling this method, let's handle it. So we can say try to run this block of code right here, which is the say hello method, and let's catch an exception. Well, the only exception that can be thrown in this case is an argument null exception. So we'll say let's catch the argument null exception. And what we're going to do is if an exception is thrown, we're just going to add to our messages list. We'll say anonymous name instead of displaying nothing. So if an exception gets thrown, we're going to inject anonymous name, and then when we print it down here, it will print that. So if we run it again, notice how the program is no longer crashing and it says anonymous name. Now, one thing I want to point out is if I add a variable here like e, this now gives me access to the exception object itself. So if I wanted to display what parameter was incorrect, let's just say, let's put a dash here, I could say e.Parm name, and this will show what parameter was the problem. So as you can see, it says the name parameter was the problem. So if there was multiple parameters here, I could use this in the caller to figure out what exactly was the problem. Was it the name parameter, or maybe was it some other parameter? So as you can see, it's pretty simple. We threw an exception and we handle it by the caller. So in this last section, we talked mainly about exceptions. We looked at how we can throw exceptions, we looked at some of the basic built-in exceptions, and we looked at how we can handle exceptions using the try, catch, and finally blocks. So that brings us to the end of the CSC108 recording. I want to say thank you for taking the time to watch and learn, and I'll see you in CSC109.